All right, as we're getting into vectors, one of the things we need to be able to do is to name directions because vectors do have a direction. And sometimes the direction's not quite as simple as up, down, east, west. It may be on the compass and it may be between a couple of directions that we normally use. So what we're going to look at real quickly today is how can we name vector and compass directions, just kind of using the typical north, south, east, west on the compass. Now, no real vocabulary today. So when we're finished with this, we just want to be able to indicate on a map, or not on a map, indicate on a compass, things like 15 degrees this way and so forth. So initially we need to just kind of review. If we have a compass setting, how many degrees would it be? So between east and north, or between east and south, or west and north. Remember, this full circle, when we draw for a full circle, is going to be 360 degrees. So there's always 90 degrees between east and north. Remember that it basically makes a right triangle, and a right triangle is always going to have a 90 degrees to it. So if we make this into a triangle, it's a 90-degree triangle, but additionally, it's also 90 degrees in terms of us thinking how far is it from east to north on a compass. Same thing from east to south, 90 degrees, between west and south, 90 degrees, and so forth. So that's just kind of our basic information we need to be able to answer some of the things we're going to go over today, because sometimes when we have a direction, it's not exactly east, it's not exactly north, it's not exactly west, or it's not exactly south. It may be somewhere in between. And kind of our system for naming this direction in between is going to be a combination of the two directions in which it's between. So in this red line that I've drawn, it's in between the north and the east. And so I would need to identify it in reference to the east and to the north, so that we can understand where it is. There's two different ways of doing this, and they actually mean different things. So the question here is, what's the difference between 15 degrees north of east and 15 degrees east of north? So they don't mean the same thing. And there's a subtle difference between the two based upon how they're written. And so what we see is that on the left, this is 15 degrees north of east. And on the right, this is 15 degrees east of north. You can see that they're in different places. They're both 15 degrees. They both have a north and an east, but the order of the directions kind of determines where we end up on this. And what we can do is kind of look at the rules of how do we get the difference between the two? What are we looking for, and what do we need to really pay attention to? So the first thing we want to think of is like the closest cardinal direction. That means northeast, south, or west. That's kind of our reference point. So whatever direction our arrow points to, we want to first identify which one of these is it really closest to. And then we're going to indicate how many degrees away from that direction is our arrow. And we're going to indicate not only how many degrees, but in which direction we would move away from that. So just to show you an example of how that would work, if that didn't quite make sense, is that this arrow, or this vector that we have that's drawn, it's not on the east, because again, this is east, and it's obviously not on the north, so it's in between the north and the east. And so I want to indicate that it is 15 degrees to the north. Notice it's moving from the north of east. So this flat line that's moving to the side like this is our east mark, and this ray is raised up 15 degrees from the east, and notice it's in the north direction. You could also have a 15 degrees south of east, which would come down this direction and be the same angle, but we would call this south of east because it's headed towards the south. The other one, the reason we say that it's east of north is because it is closer to the north. So this resultant vector we would just describe as 15 degrees north of east. In contrast, this one would be 15 degrees east of north, because north is the direction point that is closest to the arrow. And also this 15 degrees is in between the north direction and the ray that we have. So that's kind of our differences. This is 15 degrees north of east. This is 15 degrees east of north, right? So typically we're going to have two directions in our vector direction. And it tells us this first thing, this is the direction we go from. And the last direction we give is, this is kind of our baseline. This is the direction we're looking at first. So if we say 15 degrees north of east, I kind of want to start on the east direction, and then I'm going to move to the north. So north of east tells us which way to go with that. So let's look at some examples. Hopefully we can draw these out. So if I had 30 degrees north of east, I think first what we need to do is I need to look east first because I'm going 30 degrees north of that. So that would look somewhat like this, because the east is going to be a straight direction to the right and north is up. So we would be 30 degrees up from that. 40 degrees south of east, and the same thing. We look to the east first, and then our angle is going to be 40 degrees below that because south is going to be in the down direction. 25 degrees north of west would start off to the west, and then we would need to move up to the north. And this is what that angle would look like. So again, starting at the west and then moving to the north. And lastly, 30 degrees south of west, I'm going to move to the west and then move down to the south. So it gives us an idea of where to put the angle that we're at. Right. So we can try a few of these, try to name each of these angles that we have. So practice angle A. So again, notice where it is. It's between the north and right here. So this is going to be 30 degrees east of north. So again, this is the direction that we're closest to. This tells us the direction away from the other direction that we're moving. So B is 20 degrees. Again, we're closest to the east and we're moving. So it's 20 degrees north of east. C, again, 20 degrees, in which way? We're closest to the south, but we're in a little bit of an easterly direction. So this is 20 degrees east of south. D is going to be 30 degrees down from the west. So it's going to be 30 degrees south of west. And then this 45 degrees, which actually is halfway between west and north, since it's located, since we're talking about this angle in particular, we could reference E as being 45 degrees north of west. This ray could also, or this vector could also be described as, in the other direction, as being 45 degrees west of north, because halfway between a 90 degree angle is going to be two 45 degree angles. So again, this one could kind of be referenced in either direction, but the way that it's drawn with the 45 here, this is probably the better way that it's done. Okay, so again, it gives us an idea of how to be more specific about which direction something is going if it's not exactly north, east, south, or west. And that'll do it for this one.